Today, we are going to be solving a problem that comes from the 2018 Princeton University math competition. It states that if there exists a sequence of real numbers, a sub 1, a sub 2, and so on, such that for all n, the sum from k is equal to 1 to n of a sub k times k over n whole squared is equal to 1. It asks to find the smallest integer n such that a sub n is less than 1 over 2018. Before we get started, make sure you leave a like, subscribe to my channel, and let's get on with the solution. Since this problem uses a lot of confusing notation, we can plug in small values of n to better understand the problem. Plugging in n is equal to 1, the summation on the left-hand side expands to a sub 1 times 1 over 1 squared, and that is equal to 1. Solving for a sub 1 gives that a sub 1 is equal to 1. Now we plug in n is equal to 2, and we expand the summation on the left-hand side. We get that a sub 1 times 1 over 2 squared plus a sub 2 times 2 over 2 squared is equal to 1. We know what a sub 1 is. It's 1, so we substitute that back in. We get 1 half squared plus a sub 2 times 1 is equal to 1. And solving for a sub 2, this gives a sub 2 is equal to 3/4. Now we see that as we go up in values of n, we're kind of recursively finding the values for a. Moreover, since we want to find n such that a sub n is less than 1 over 2018, it looks like it's going to take a while. It might be the case that after we plug in hundreds or maybe even thousands of values of n, we still won't find a sub n that is less than 1 over 2018. So we look for a smarter solution. Let's really consider the equation that we have at hand. Notice that since this n term in the denominator does not depend on the index k, we can pull it out of the sum. More intuitively, we can see that for each term in our sum, there is a 1 over n squared, and so we can just factor out the 1 over n squared from the sum. This gives that 1 over n squared times the sum from k is equal to 1 to n of a sub k times k squared is equal to 1. We can multiply both sides by n squared, which gives that the sum from k is equal to 1 to n of a sub k times k squared is equal to n squared. Okay. Since this equation holds for all n, it'll also hold for n minus 1. So we replace n by n minus 1, and this gives that the sum from k is equal to 1 to n minus 1 of a sub k times k squared is equal to n minus 1 squared. Now here comes the trick. We subtract the bottom sum from the top sum. A lot of terms on the left-hand side cancel out. The only term that's left on the left-hand side is for when k is equal to n, which is a sub n times n squared. And the right-hand side becomes n squared minus n minus 1 squared. If we expand the right-hand side, we get n squared minus n squared minus 2n plus 1. And this can be rewritten as 2n minus 1. We can divide both sides by n squared, and this gives that a sub n is equal to 2n minus 1 over n squared. It looks like we're in good shape because we found a sub n in terms of n. Remember that the problem said to find the smallest n such that a sub n is less than 1 over 2018. So that means we want to find the smallest n such that 2n minus 1 over n squared is less than 1 over 2018. So now the question is, how do we find the smallest integer value of n? Let's just test out n is equal to 500 and see what happens. We get 2 times 500 minus 1 over 500 squared, which is equal to 2 times 500 is 1,000. 1,000 minus 1 is 999 over 500 squared should be 250000. The numerator is really close to 1,000, so let's just pretend it's 1,000. We cancel out some zeros, and we see that we only have 1 over 250. So we know n is going to be really big. Okay, so We know we're dealing with really big values of n. And if you know a little bit of calculus, specifically limits, you might notice that this -1 will become negligible. To see this more explicitly, we can rewrite the left-hand side as 2n over n squared minus 1 over n squared, which is less than 1 over 2018. This rewrites as 2 over n minus 1 over n squared is less than 1 over 2018. We see that for high values of n, this term goes to 0 very, very fast. And so we kind of really only have to consider our 2 over n term. We note that 2 over n minus 1 over n squared is less than just 2 over n by itself. And I hope you can see where we go from here. If we plug in n is equal to 2 times 2018, which is equal to 4036, we get that the right-hand side is equal to 2 over 4036, which is just equal to 1 over 2018. And so we are done. We found our n such that the left-hand side is less than 1 over 2018, which is what the problem asked for. Good job, guys. Thank you for watching the video. If you have any suggestions or critiques of my solution, please feel free to leave it in the comments. If you enjoyed this video, please make sure you like and subscribe, and I'll see you next time. Peace out.